So the Overton window has shifted again, and what I want to talk about today is kind of the question of how smart can AI get, really, and can we keep up? Now, of course, the conclusion of this video is very simple and straightforward, which is AI can get very smart, and can we keep up? No, not on our current hardware. That pretty much goes without saying. Now, of course, there are corners of the scientific community and the technical community and the business community and the internet in general that still, of course, are skeptical about this. But what I really want to do is try and characterize what are we actually going towards. So this is an extension of the conversation around, what is artificial general intelligence and what is artificial superintelligence. Now, I find both of those to be kind of useless terminology, but this graphic was kind of the inspiration for this. And for some context, this was inspired by the Jagged Frontier paper and blog post by Ethan Mollick, which many of you have probably heard of. The very short TLDR is that AI tends to surge forward in some domains and lag in others. And this was a meme. This was a version that was created by a Twitter denizen. And he said, this is my take on the Jagged Frontier. And so we're transitioning from here to here, particularly, as of late 2025 and through 2026 and 2027. Now, the gray circle is, all the tasks that a human can do that are economically valuable, right? So that's the kind of the Sam Altman and OpenAI definition of AGI, which is AGI is something that can do all tasks that a human can do that are economically valuable. That's a good, concrete, empirical term. Not everyone agrees with that definition, and of course, AGI is a very squishy science fiction definition, but this graphic does a good job of showing that, originally AI was a subset of human tasks, meaning there was nothing that AI could do that humans couldn't do, and that humans couldn't do much better. And what we've just passed in 2024 and 2025 is that there are economically valuable tasks that generative AI and cognitive architectures and agents are now able to do better than humans. And that kind of goes back to my mantra of better, faster, cheaper, and safer. And then where we're at is the transition to where there's only a couple things left that humans can really do better. So the kind of the tagline here is where we were at or where we are at is AI has a jagged frontier. Sometimes it's amazing and sometimes it's really dumb. The next step in this is the AI is unbelievably intelligent, but for some reason it still fails at X. Now, of course, some people are out there thinking Moravec's paradox. And if you're not familiar with Moravec's paradox says that for whatever reason, humans are really good and can easily do some things that machines really struggle at, like walking. However, that is no longer a moat. As you've probably seen out there, there are plenty of robots that are better at parkour and running and balance than most humans, other than maybe some Olympic level gymnasts and that sort of thing. Now, of course, obviously, there's plenty of tasks and skills that humans have, wielding hammers, building houses, those sorts of things. But the gross motor skills of humanoid robots are really good. And so that's an example of where we are seeing machine capabilities becoming superset or exceeding human capabilities. And that is what this paper is about, or this blog. So the first idea that really kind of crystallized this for me was this little formula here, M superset H. Let M be the sum total of all capabilities of a machine, and that is superset of humans. So if M is superset H, meaning that at some point in the future, machines will have all the capabilities of humans and more, because superset, this symbol is greater than, basically. It's not greater than or equal to, it's greater than. So M superset H. That's really kind of what we're talking about here, and that's what this graph shows, is that whatever you call a quote AGI is going to be superset of all human tasks. Now, of course, as I said at the beginning, there are plenty of people that are skeptical about this, but from a first principles perspective, from a math and physics perspective, there's nothing unique or special that a human brain is doing. We're a massively parallel cholesterol-based computer. That's what you have in your head, unless you make the assertion that human brains exploit quantum physics and are basically quantum computers, or receive signals from the ether, something metaphysical or quantum, but there's not really much evidence that that is the case. Now, we probably do exploit things like there's quantum tunneling effects that our neurons do exploit, but that is still basically at the macro level. That's still kind of a mechanistic way of creating gates, as far as I know. I could be wrong. There's also theories that the brain waves, that the actual electrical and electromagnetic pulses that propagate across the brain are part of the calculation, meaning that your brain might not work without those. So, sorry for all the Ship of Theseus people who think that you can replace your brain piece by piece with electronics. It's entirely possible that even your sense of consciousness is predicated upon the global net effect of those electromagnetic waves. There we go. Sorry. So when you look at all the matter and energy that goes into human cognition, it seems like there's multiple layers to it, but all of it is measurable. And so if it's all measurable, that means that it is all physically real. And if it is all physically real, it means that all our brains are doing is just exploiting physics and math as we know it. Therefore, machines, since they also exploit physics and math as we know it, therefore there's nothing that would prevent M from becoming superset of H. So the reason I'm saying this is just because this is the most formal way of saying, what do we mean by superhuman intelligence? And so when we say capabilities, intelligence is kind of squishy and that sort of thing. It's like, well, we can't even define intelligence. But the thing is, there's a few like rhetorical and cognitive biases and logical fallacies. But basically, whenever you say like, well, we can't even define AGI, that's a thought-stopping technique. Because the implication is, therefore, we don't even have to contend with the possibility of M superset H. However, forget about AGI, forget about ASI for a little bit, and just say, what if M becomes superset of H? What if machine capabilities are superior to all human capabilities in the long run? Whether you believe that's months away or whether you believe that's years away or decades or impossible. Now, plenty of people have the emotional reaction that it is impossible. However, any of those assertions require testing, right? If you say machines will never be better than humans, that still requires evidence. Any claim, positive or negative, requires evidence. And of course you can say like, well, you can't prove a negative. And right now you can demonstrate, you have evidence to say humans are still superior than machines at some things. This is the whole jagged frontier conversation. And the reason that this was the inspiration for me is because this is what I really sense out there, and this is coming not just from the scientific community, not just from the technical community, but also from the business community, is that more and more people are accepting that we are seeing the jagged frontier, and if it continues to expand, then human capability, like we might have a couple little holdouts for a while, but there's no physical reason to believe that will last forever. So with that being said, the next logical question is, well, what are the limits? Because when I've polled my audience before and I've talked to people, some people believe that there is literally no physical limit to how smart artificial intelligence can be. However, math and physics doesn't really allow that. So first, let me just give you, I guess, a little bit of background. So what I've done is I've spent some time thinking about like complexity theory and, P versus NP and those sorts of things. And what I'm trying to do here with these axioms that I'm sharing is simple notational ways, formal notation, to basically say where is it that machines exist versus humans. So axiom 1, the bounding box of universal supersets. So let us first assert that physics, so in this case, physics is everything that the universe can actually do. Every computation or algorithm or calculation that the physical universe is capable of is superset to math. So math is just whatever operation we can define with symbols and notation, because human math is not able to fully represent reality. It is a shadow of reality. It is a representation of reality, but it is only ever a representation. It is not a perfect representation. And the totality of math is still superset to what a physical machine could actually do. Because a physical machine is a device that runs on electricity or thermodynamics or photons or whatever. And so it's never going to be quite as perfect as pure math. And then, of course, machine capabilities or machine computations are, of course, based on this question, superset to all human capabilities, because while our brains are an information processing organ, it is limited in its architecture, its design, its size, just strictly the amount of energy that we can use. Our throughput in bits, our energy consumption, all of that limit us in ways that machines are not limited. And by the way, Max Tegmark talks about that in his book Life 3.0, which is really good. I do think that Max has gone off the deep end a little bit, although he is distancing himself lately from the more violent rhetoric of the doomers. So, if we accept this axiom, and again, these are axioms, so these are assertions. These are not proven. Nobody has accepted them. These are just my ideas, the way that I am trying to communicate this. So I want to clarify that these are not universally accepted assertions. These are things that I am coming up with based on my understanding of math and physics and machines. So, take it with a grain of salt, but I hope that it helps provide some clarification. So that was axiom 1. Axiom 2 is limited time horizons. And by the way, there's 6 axioms, and then I am building to a point, so just stick with me. Limited time horizons. So TLDR, due to chaos and complexity, because there is chaos in the system of reality, that therefore implies that the horizon, which is the maximal time horizon that you can meaningfully anticipate of that system, is less than infinite. Meaning that beyond a certain point, you just cannot predict reality. So for chaotic systems, more compute does not equal infinite foresight. There is a hard time horizon where extra intelligence stops helping. Sorry, Harry Seldon. Basically, whenever, and there's a few physics principles, but whenever you have a complex chaotic system, then there is going to be divergence, even if you have 2 copies of the same exact system that have the initial starting conditions that are identical. Because of chaos and because of chaos theory, there's going to be some level of divergence, meaning your math cannot perfectly represent every variable in a chaotic system. It's just not possible. And then you have a butterfly effect of compounding divergence, meaning that yes, over a certain time horizon, you can predict pretty accurately. If you look at prediction markets and super forecasters, this is actually a study that I've done. The vast majority of super forecasters completely fall apart beyond 18 months. So, the best that a human brain can do with experience and intuition and all the strategies is about 18 months. Beyond that, human super forecasters completely fall apart. Very rarely do they go any beyond that, but that seems to be a very meaningful, reliable wall of human prediction power. Now, could a machine go a little bit further? Absolutely. When you look at all the other characteristics that we're talking about in which humans are going to be inferior than machines, absolutely. It is entirely possible that machines' forecasting capability could go beyond the 18-month super forecaster horizon, but it gets exponentially or quadratically or factorially or super exponentially more difficult because the chaos of the system continues to compound over time, meaning no amount of intelligence can overcome the chaos wall. So that's point number 1. And so next is the complexity wall. And so this is the, how do we articulate P is not equal to NP, which is polynomial versus non-polynomial problem space. How do we articulate this in an axiom? And so in this case, hard P, so hard problems imply, so the existence of hard problems imply that the time of an agent to perform those or to solve those problems explodes. And so the idea is, put simply, there exist problems where there exist problems P where no agent gets a fast, exact solution. Smart human, smart alien, God, doesn't matter, the runtime blows up. In other words, there are no problems where more intelligence does equate to faster, more exact solutions. Sorry, that's a little bit of a typo. Even if the solutions are easy enough to validate, interestingly. And so an example here is, you might calculate that you have invented warp drive, and you have all the math showing this craft should travel faster than light. No amount of math and proofs matter to whether or not your warp drive actually works and actually gets you to Jupiter in just a few minutes rather than a few hours, or however long it would take us to get to Jupiter. Next is the signal ceiling. You cannot extract more signal from noise than actually exists. So therefore the info of data, so the amount of info or information that an agent X can extract from data from raw noise or from raw reality is less than or equal to the actual amount of information in data. Now, that might be a little bit confusing, so I came up with this metaphor for it. So it's fun to imagine that Sherlock can pick up on tiny clues like a quantum computer and triangulate what must be true from vanishingly tiny amount of information, tiny clues. You might argue that this is human intuition, and at a certain point, clues plus guess and check plus elimination of the impossible could result in a Sherlockian or Whovian level of wit. At the same time, this is fantasy. Just because you can imagine it does not make it real, despite what some philosophers would argue. Meaning that if the information simply does not exist in reality, you cannot just fabricate that. No amount of intelligence can create signal where there is none. Now, that doesn't mean that there aren't workarounds. I mean, we use guess and check, we use process of elimination, and we use reasoning from first principles and heuristics and that sort of thing. But at the same time, no amount of intelligence in a vacuum is going to be able to cure cancer. You can't just reason from first principles to cure cancer. Just like you can't reason from first principles to understand what artificial intelligence is actually going to do when we actually invent it. That is a jab at the doomers, by the way. Next up is the bandwidth gap. So this is something I alluded to earlier, which is the bits of humans, so the amount of informational throughput that a human can handle is far less than the amount of information throughput that a machine can handle. That is just simply a fact. And both of those are less than infinite. Now, what this does is it sets the bounds to say, okay, just from observed engineering principles, machines are far faster than humans. That seems to be a pretty simple axiom. And of course, machines do have physical limits. There is a finite amount of time, energy, and matter in the universe with which they can use. And I know that some people talk about computronium, but the universe is computronium. Like if you want an information processing substrate, that is the universe. That is reality. That's what reality does. So you cannot exceed computronium or the substrate of reality. A machine is still built of the same stuff. So you're building an intelligence simulator on the real intelligence computer of reality. I hope that makes sense. Then axiom number 6 is cognitive horizon. So this is something that I've talked about a few times before on my channel and other places. So the cognitive horizon is the maximum set of understandings that an agent can possess. This is defined by the set of cognitive primitives, which are the mental artifacts that can be intuitively rendered by an agent, and the cognitive operations, the manipulations of those artifacts. So an example of an artifact is if I say a basketball, you intuitively can immediately just say, basketball. You know, it's about so big and it bounces and they're usually orange, but they can be other colors. And I know how to, dribble a basketball, and I know the physics of shooting a basketball, at least intuitively. So you have a cognitive primitive, or you have cognitive primitives in your brain that allow you to construct the artifact of basketball. And that is very intuitive. It does not require any extra thinking or effort on your part. It is something that it is the kind of primitive that the computer of your brain is optimized for. Now, what this says is that the cognitive horizons of humans are subset to the cognitive horizons of machines, which of course are subset to the potential maximum reality of physics, meaning that you probably cannot create a mental artifact of everything that physics can generate. Another way of thinking about this is like a hyperobject. So when we talk about a mental artifact, you might say, well, I have an intuitive understanding of social media because I've been on social media. I know what the algorithm is. So the algorithm is an example of a hyperobject where it's not just one thing. It is the interaction of billions of humans and on millions of computers and lots of social media and memes and the minds of other people. So you have a hyperobject where social media and the algorithm is a hyperobject, and that is within your cognitive horizon because you have the cognitive primitives of theory of mind and relationships and those sorts of things. So you have all the cognitive primitives to understand intuitively what social media is, even though you've probably never formally defined it. Now, there are probably hyper objects that are well beyond our cognitive horizons, like fusion reactors and longevity and the entire genome. So imagine that in a few years, we invent a large language model that can look at your entire genome and hold that in its mind as a single hyper object. That it can say, aha, I intuitively understand that if I poke your genome over here, you'll live longer. And if I poke your genome over there, then you're going to be more resistant to cancer. And so that's what I mean when I say intuitive. It's intuitive, meaning that it's just the fundamental nature of the processing that agent or that entity does. It doesn't require any extra thought or any extra work. And then what you do is you say, I have this intuition. How do I now test that? And so, to put it simply, machines can intuitively grasp mental concepts that humans physically cannot. Consider calculus and exponentials. We have no intuition for these because we evolved locally and geometrically, whereas machines like AlphaFold can develop intuitions for complex proteins, exponentials, and more. So those are the 6 axioms. And you might say, okay, how do I put all those together in my head? How do I now create a cognitive primitive for this? And for that, I created a couple memes. So the primary cognitive primitive here is the sigmoid curve and the ceiling, or the asymptote. So you look at all of those axioms that we've put together where there are known and knowable and perceivable or predictable limits to math and physics. Altogether, I believe that will create a ceiling of useful intelligence. So here's an example of why I believe that there is probably going to be a hard ceiling of useful intelligence. Now, that might be the equivalent of IQ 300. It might be the equivalent of IQ 3000. We don't know where it's going to be. And remember that IQ measures human intelligence, and that machines with their jagged frontier, IQ is probably not a good measure in the long run, just because it's going to have cognitive primitives and cognitive horizons that we really are truly ineffable to us. But computational complexity, P not equal NP. Intractable problems in exponential search space exist. Eventually, it's just going to take too much math. Like, long story short, it's just some things are just not worth calculating. It's going to take entirely too long to calculate them, so don't even bother. Next is the Lyapunov horizon. So that's the chaos that we were talking about earlier. And if I mispronounce that, I apologize. So prediction limits due to inherent noise and the unpredictability of chaotic systems, meaning that things just diverge more and more and more. And no amount of intelligence can anticipate all of that. So you have, those are the first 2. Number 3 is computational irreducibility. Simulation is the only path, no shortcuts. So what this means is that eventually you just have to wait for reality to show you what the actual outcome was. And then finally is Kolmogorov complexity, or entropy. So incompressible data and pure noise. Eventually, there is just no more signal to extract from the noise. And so eventually, what you're going to be optimizing for is, how do we get the same level of intelligence with fewer joules, with less energy input? All right, I got interrupted, so I don't remember where we were. Anyways, simple graphic. Oh yeah, so where we're at is that humans are going to be forever down here somewhere, and machines are going to approach closer the ceiling of useful intelligence than we ever will. So, you might even say humans are like way down here, and, AlphaFold is here, and, GPT-8 will be there, and Gemini 12 will be there, something along those lines. But the point is that we will see diminishing returns. And when we say diminishing returns, what we mean is that there will come a point where additional intelligence does not yield better outcomes. Yes, we could hypothetically make a universal God mind, but it's not due to all of the mathematical limits, such as P equals not equals MP, due to chaos, due to entropy, due to irreducible complexity, or computational irreducibility. Due to all of those reasons, eventually you're going to get a better payoff from just making the smarts that you do have less energy intensive, which then translates to faster and cheaper. So that's where we're heading. So the thermodynamic efficiency era. Now, the last thing is this graphic, this meme that I created, which talks about kind of the cycle that we're going through. So this is kind of the bottom line. So what what does this have to do with us? So first and foremost is the cognitive primitives and cognitive horizons. There we go. So human cognitive primitives are here, where we have an intuitive understanding of three-dimensional space, a little bit of linear time and causality, and social networks and that sort of thing. But AI cognitive primitives are going to include everything that we have, and then a lot more, such as non-Euclidean geometry, complex tensors, large-scale network topologies, and that sort of thing. So we can anticipate a future, likely in the near term, certainly within the next several decades, if not within the next several years, where human cognitive horizons are completely subset of AI cognitive horizons. So then what that becomes is what you might call the pigeon paradox, or the ineffability of machines. So if something is ineffable, it means that you just can't understand it. It is literally beyond your ken. So that's Ken, which is a word for meaning, mind. You cannot wrap your mind around it. So we do have an analogy for this, which is pigeons. If you spend all day trying to teach a pigeon chess, it will never understand chess. It can't understand the board. It can't understand pieces. It can't understand any of the abstractions required. It can't even understand the idea of winning, at least not in the abstract. So a pigeon's cognitive horizons are very, very limited, and so we have an intuitive understanding as to what it means to have a much larger cognitive horizon than another entity. But the role will be reversed, where humans are going to have the inferior cognitive horizon compared to the machine. This seems mathematically inevitable. Well, maybe inevitable isn't the right word. Maybe mathematically likely, mathematically probable that machines will have a superior cognitive horizon to us. Now, one advantage, though, is that humans and machines both operate in reality. So this is the discrimination factor, and I don't mean that like prejudice. I mean that while reality is noisy, there is a ground truth. There is a physical ground truth, which is sometimes it's the amount of energy that we're producing and using. Sometimes it's, when you have the right medicine and it treats the right disease, everything else is just noise. I just went through this personally, where every single symptom I had and every single lab test that I did, most of it was noise. And so it came down to my intuition and my research and learning with the help of AI to figure out this is exactly what's wrong with me, and this is exactly what I do to treat it. This is where we have kind of the great equalizer. And calling it an equalizer is not necessarily the right term, but humans and machines will both operate in reality, which is like, does the device work? Yes or no? Are you alive or dead? Yes or no? A lot of things come down to just very basic, observable, measurable things. This is what I mentioned earlier, which is because we operate in a world of matter and energy, it means that everything that matters is measurable. So that means outcomes are measurable. That means diseases are measurable. That means energy is measurable. Therefore, we still have a way to verify, meaning AI might be able to intuitively figure out how to create faster than light travel. But that intuition, even though the AI might be infinitely more intelligent than us, the intuition still has to be proven out in physical reality. So the signal there is, did you actually make warp drive? Did you actually get to Proxima Centauri faster than light would have actually gotten there? So because of that, because humans have already evolved in a messy physical world where the outcome is the true test of things, that is still going to be something that we have in common with machines, but their intuitions will appear to be pure magic to us. Because think of it this way, we build AGI, we build a supercomputer, whatever it happens to be, and the computer says, aha, I have just intuitively figured out how to cure cancer. And then it's like, great, prove it. And it's like, okay, well, here's my intuition, here's the machine intuition, so let's put the AI's intuition into, a petri dish and prove it out. And because of those previous issues, again, even if AI thinks that it has a perfect solution, there are limitations. There are just physical and mathematical limitations to what any intelligence can do. Therefore, reality remains the test. Now, the final point that I want to leave you with, here's what I personally anticipate as the outcomes. So first, machine cognitive primitives and cognitive horizons will and likely already include primitives beyond what humans can. Meaning humans are probably already subset to machines. And this goes back to this very first graphic, which is you can superimpose this graphic and you can talk about economically valuable tasks. You can also talk about cognitive horizons and cognitive primitives. Same graphic represents the same idea. So that's kind of outcome number one. This seems like a basic thing, and I know that in my audience I'm preaching to the choir, but not everyone will agree. Therefore, what that entails is that machine cognition will eventually become ineffable to humans due to our lack of cognitive primitives, like trying to explain chess to a pigeon. The game of chess is ineffable to a pigeon. Likewise, there's going to be things that AI can come up with that are just ineffable to us because we lack the neurological hardware to even begin to understand some of these things. Next, is one advantage is that reality is often coarse-grained. That's what I talked about, where there is a real signal in the noise, meaning something is measurable, and you can point at that measurable thing, whether it's matter, energy, or an outcome, and you can say, well, that's the real test of it. While machines might be better at finding the signal in the noise, we both operate in shared reality. If something does not interact with matter and energy, then it cannot be measured. If it cannot be measured, it is not real. Now, I'm using real in the materialist standpoint here. I put real in quotation marks because I know that from some philosophical perspectives out there are plenty of things that are, quote, real that are not represented in matter and energy and are not measurable. But even if it's in your brain, that's matter and energy. But then, of course, some philosophers will say, well, how do you know that matter and energy exist? And monism and dualism and blah, 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 and panpsychism, whatever. I'm not talking about that. I'm talking about physics and science. So anyways, and then therefore, finally, and since we share physics, matter, energy, and measurement, humans will still likely be able to validate the machine intuition, meaning, machines might say, hey, I figured out warp drive, or I figured out, cancer, or whatever. There is still going to be an empirical physical test to demonstrate. So if the machine says, I intuitively understand nuclear fusion, it's like, great, build a fusion reactor for us then. Now, of course, what this does not imply is that machines will automatically be dangerous or safe. That's not what I'm talking about here. I am merely trying to rigorously characterize that we are on a trajectory and that the axioms that I shared, if they are true, there are some entailments that we can anticipate. Now, of course, I'm using the same, first principles reasoning that I criticize of, people like on Less Wrong and the Doomers and the Rationalists and that sort of thing. So that's why I want to be very careful here and not jump to conclusions to say, even if all of this is true, it doesn't necessarily mean that AI is going to be inherently dangerous or inherently safe. And that's the same thing that Geoffrey Hinton has been talking about, which is, he uses the chicken analogy. He's like, oh, well, if you want to know what it's like to be not the most dominant species on the planet, then look at a chicken. Look at how we treat chickens. The difference is chickens are tasty. And I know that sounds flippant, but chickens, the reason that we factory farm chickens and that is bad for their welfare is because they taste good to us, because they are immediately useful to us. The vast majority of living things we don't care about. We don't care about pigeons and mole rats and worms, and if anything, we have learned to maintain their survival because it's good for the ecosystem. Now, you might say, well, the only reason that we preserve the ecosystem is out of rational self-interest, which I would tend to agree that, if we didn't need worms and moles and fungus and all that other fun stuff, then we would just say, who cares? Kill it all. And of course, we do kill a lot of things by putting ourselves first, like when we build cities and we build houses and we put down power lines and build power plants. Lots of things die. And of course, lots of people say, well, even if machines do the same thing, they might say, well, there's plenty of humans. Who cares if we accidentally eradicate half of humanity? We need to build our antimatter power plants. I'm not talking about any of that stuff. While those are somewhat logical, intuitive leaps, that's not what I'm talking about here. All I'm talking about is how do we characterize machine capabilities versus human capabilities? And the reason I think that it is, just kind of to put a bow on it, the reason I think that it is time to have that conversation is because the Overton window has opened enough where we can say, hey, we tend to agree, we have arrived at consensus that there is a jagged frontier. What happens next? It doesn't mean that it's automatically dangerous. It doesn't mean that it's automatically misaligned, and so on and so forth. So I want to dial back from there. The whole point is because my wife asked me, like, what are you making a video about? And I said, we need to have the conversation as broadly as possible to recognize and see if we can agree or come to consensus that we are working towards a world where human capabilities are subset to machine capabilities, or M superset H. If we can agree on that, if this is the most likely outcome, then the Overton window has shifted and we can have the next conversation, which was, what does that mean for us economically? What does that mean for us existentially? What does it mean, so on and so forth. But I don't want to jump to conclusions. All right, I'm done repeating myself. Thanks for listening. Take care.